Okay, here's the last video on squares and tilted squares, and then finally the Pythagorean theorem. So the idea of the Pythagorean theorem is we have, when we look at triangles, right angle triangles, with say length x, height, or length y, height x, and then we have something called the hypotenuse, which is this length. So the hypotenuse is the longest side. So Pythagorean theorem is that x squared plus y squared equals h squared. It's the so if you take this length, you square it, this length, square it, you get that length squared. So we're going to look at how we could prove it using this idea of tilted squares. So here we have our tilted square again. We have some distance here, x, and some y, and some distance x, y, some distance y, some distance x, and then so this thing would be the s. So s is not only the length of the square, it's also the hypotenuse. Okay, now here's what we've done for this kind of proof. We've redrawn all those shapes and put them into these shapes. So a little bit of thinking, we can see that actually these two things are the same. I have four triangles this side, and we've just rearranged them this way. So we kind of rearranged how the triangles sit, and then that splits up the gray stuff into two different sections. So here's part of the gray section, and then here is the other part. And when we do that, we can see that the area of this is y times y, or y squared, because this is y. And then the area of this guy is x times x, or equal to x squared. So we could say the shaded or tilted square has area equal to y squared plus x squared. We also know, because of properties of squares, that the area of the square is equal to s squared. So we know that s squared is equal to x squared plus y squared, and we also know that this s is the same as that hypotenuse, and that's the Pythagorean theorem. How it's used is the idea that if I say, okay, well, I have a triangle here, this is 4 and this is 3, what's the length of that triangle? Or what's the length of this side? Well, we could say this is h, so h squared equals 3 squared plus 4 squared. H squared equals 9 plus 16. H squared is equal to 25. So h is equal to 5. That's a nice easy triangle to calculate. Another example would be maybe, just pick anything, 6 and 7. Well, it looks a little bit backwards, right? This one's the longer one, 7 and 6. What's h equal to? H squared is 6 squared plus 7 squared. So it's 36 plus 49. So h squared is equal to, what's that, 50, 85. So h is equal to, well, we don't know what that is, the square root. Like, I know that 9 squared is 81, and 10 squared is 100, so it's just over, it's a little bit over 9, it's maybe 1.9, 9.1. But we could also just say it's the square root of 85. One last thing is, if you're ever having problems remembering what the Pythagorean theorem is about, here I'll go through what actually Pythagoras did with his theorem. So what we did there was a proof that's kind of For some people it's easy to understand, but this is really what Pythagoras was saying. It's the same thing, but put into different words. If you have a right angle triangle, and if you consider the squares, they're made from the sides of that triangle. So we could say maybe this is side A, side B, and side C. If you take the area produced by side A, so call this area 1 equal to SA squared, and then you have area 2, which is SB squared, and then area 3 is equal to, it's kind of messy, is equal to SC squared. What Pythagoras' theorem says is that the area of 1 plus the area of the 2 is equal to the area of 3. So this is something you can always sort of fall back onto. If you can recreate this drawing for right angle triangles, that really can help you step towards how the theorem is used. So how that translate here is this is equal to area 1 is SA squared plus SA, area 2 is SB squared, area 3 is SC squared. Or actually quite often we see this written as A squared plus B squared equals C squared, like this. A, B, C. And that this is the most common way that we actually see Pythagorean theorem. A squared plus B squared equals C squared, where C squared is the hypotenuse.